The Goliath. In 1942, the German army issued a tracked mine that weighed 370 kilograms, carried 60 kilograms of explosives, and was steered by a joystick connected to the vehicle by 2,130 feet of cable. The operator sat at one end of the wire. The Goliath crawled toward the target at the other. The concept was straightforward enough. Drive it under a tank, detonate it remotely, destroy the tank without risking a soldier. Carl Borgward, the same engineer who would later build automobiles under his own name, developed the original design. A single gasoline engine version cost around 3,000 Reichsmarks to produce. An electric version followed shortly after. By the end of the war, approximately 7,500 had been manufactured across both variants. The tactical results were mixed, and that is being generous. The cable could be cut. Soviet and Allied soldiers learned quickly that severing the control line left the Goliath sitting motionless in the open. The thing that was supposed to destroy tanks could be neutralized by a pair of wire cutters. The Schwerer Gustav. It took Krupp engineers from 1934 to 1941 to build it. The barrel was 32 meters long. The shell weighed 7 tons. The caliber was 800 millimeters. It was the largest artillery piece ever used in actual combat, and it required more than 2,000 personnel to transport, assemble, and operate. A dedicated railway line had to be constructed before the gun could fire a single round. Anti-aircraft batteries were deployed specifically to protect it during assembly, which took several weeks. The target it was designed to destroy was the Maginot Line. By the time the gun was operational, German forces had bypassed the Maginot Line entirely by going through Belgium. The Schwerer Gustav was redirected to the siege of Sevastopol in 1942, where it fired 48 rounds against Soviet fortifications and reinforced ammunition bunkers buried under the harbor. It worked. The shells penetrated 30 meters of earth and detonated a Soviet ammunition magazine the Germans had been unable to reach by any other means. After Sevastopol, the gun was moved to Leningrad, where it fired nothing. It was then prepared for deployment to Stalingrad. The situation there resolved itself before the gun arrived. Gustav fired fewer than 300 rounds in total across the entire war. Both guns built to this specification were demolished by German forces in April 1945 to prevent capture. The engineering resources devoted to the Schwerer Gustav were staggering. The logistical chain required to keep the weapon operational was longer and more complex than the chains supporting entire divisions. Each round fired required calculations performed by specialized personnel. The gun's slow rate of fire, sometimes separated by days as the massive structure was repositioned and recalibrated, made it impractical as an integrated component of any coherent tactical doctrine. The psychological impact of the weapon may have exceeded its material contribution to any single engagement. When the gun was deployed, it drew extraordinary attention from both German command structures and Allied intelligence services. Multiple bombing raids were planned specifically to interdict the weapon's supply lines and movement. In terms of military return on investment, the Schwerer Gustav represented one of the war's most extravagant expenditures, producing one of the war's most negligible tactical results. Project Habakkuk. In 1942, a British inventor named Geoffrey Pike proposed building an aircraft carrier out of ice. Not metaphorically. A literal floating structure of frozen water, 1 mile long, 200 feet in draft, displacing 2.2 million tons. To be stationed in the mid-Atlantic as a refueling base for patrol aircraft. Steel was in short supply. Pike's solution was to mix wood pulp into water before freezing it. The resulting material, which he called pikecrete, was genuinely impressive on its own terms. It was harder than plain ice, it melted more slowly, and it could stop a bullet. A small demonstration block was placed in front of the Combined Chiefs of Staff in Quebec in 1943. Lord Mountbatten, reportedly, dropped a piece into a swimming pool. Winston Churchill gave the project formal approval the same year. The engineering obstacles were enormous. Keeping a mile-long structure frozen in the North Atlantic required a refrigeration system running on 33,000 horsepower. The estimated construction cost exceeded $700 million. Building a prototype in Patricia Lake, Alberta in 1943 demonstrated that pikecrete worked as a material. It demonstrated nothing about whether a vessel of that scale could be built, crewed, maintained, or used in combat. The project was quietly abandoned in 1944 when enough conventional escort carriers had come off American production lines to make the problem moot. The prototype in Patricia Lake was allowed to melt. The remains are still at the bottom of the lake. The Panjandrum. In 1943, the British Directorate of Miscellaneous Weapons Development was looking for a way to blow a large hole in the Atlantic Wall to allow tanks off a landing beach. The solution proposed was two 10-foot wooden wheels connected by a central drum packed with 2 tons of high explosive, propelled forward across a beach by cordite rockets attached to the rims of both wheels. The rockets would fire, the wheels would turn, the device would roll at approximately 60 miles per hour directly into the concrete fortification and detonate. In principle, the explosive payload was sufficient to open a gap large enough for an armored vehicle. The tests at Westward Ho Beach in Devon in November 1943 did not confirm the principle. Rockets detached from the wheels and fired in random directions. The Devon device veered off course. On one occasion, it turned around entirely and headed back toward the observers and the film crew that had been invited to document the trial. The pigeon-guided was never used in combat. The footage of it careering across the sand in all directions survived and has been shown regularly ever since. The committee dissolved. The Atlantic Wall problem was eventually solved by conventional explosives and armored engineering vehicles. The fundamental issue with the pigeon-guided lay in the instability introduced by asymmetrical thrust vectors. The rockets, even in pairs, could not be mounted with sufficient precision to guarantee balanced firing. The wooden construction swelled and warped as it absorbed moisture from the sea spray. The explosives themselves were packed inconsistently, creating variations in the center of gravity that compounded the directional problems. British engineers had attempted to solve similar mobility problems through numerous other experimental designs, before settling on the pigeon-guided concept. Many involved tracked vehicles with specialized charges, others relied on explosive propulsion entirely. The pigeon-guided stood out primarily for its uncontrolled visibility as a failure, captured on film by the documentary crew that had been invited to observe the test. The technical failures were not unusual within the portfolio of miscellaneous weapons development, but the comedic element of the footage ensured it achieved a cultural longevity that more successful projects never attained. The Bat Bomb. In early 1942, a dental surgeon from Pennsylvania named Lytle Adams submitted a proposal to the White House. He wanted to attach small-timed incendiary devices to live Mexican free-tailed bats and drop them in canisters over Japanese cities. The bats, on release, would disperse across a wide area, roost in the wooden structures that made up much of urban Japan, and ignite fires simultaneously across multiple city blocks. The logic was not entirely without merit. A single canister could theoretically deliver hundreds of bats. Each bat could carry an incendiary device weighing around 17 grams. The fires would start inside structures, in locations difficult to access for fire crews. The National Defense Research Committee approved the concept for development. Around 6,000 bats were captured. Incendiaries were designed and attached. In May 1943, during a test at Carlsbad Army Airfield in New Mexico, several bats carrying live incendiaries escaped from the testing facility. They roosted under a fuel tank and in the ceiling of a general's staff car. Both burned to the ground. The Marine Corps took the project over the same year and ran 30 additional tests at a total cost of $2 million. Development was canceled in 1944. The official reason given was that the atomic bomb program was absorbing priority resources. The project director maintained until his death that the Bat Bomb, if deployed, would have been more effective against Japanese cities than the weapons that were ultimately used. The Soviet anti-tank dogs. By 1941, the Red Army had trained an estimated 40,000 dogs to carry explosive charges under German tanks. The training method involved starving the animals and hiding food underneath Soviet tank hulls so that the dogs learned to associate the underside of a tank with feeding. A wooden lever extended upward from the explosive pack on the dog's back. When the animal crawled beneath the tank and the lever depressed against the hull, the charge detonated. The program had been in development since the early 1930s. The operational results were poor. Dogs trained on Soviet diesel tanks encountered German petrol-engine vehicles and frequently turned back. Some returned to Soviet lines and detonated among their own troops. German infantry were instructed to shoot any dog sighted on the battlefield on sight. By the middle of the war, the program had been significantly reduced. Official Soviet records claim the dogs destroyed more than 300 German tanks. Independent verification of that figure has never been established. The Krumlauf. In 1943, German engineers attached a curved section to the barrel of a standard MP44 assault rifle. The attachment bent the barrel at 30 degrees. A second version bent it at 90 degrees. A mirror mounted at the curve allowed the operator to aim without exposing his head around the corner. The 90-degree version was intended specifically for use inside armored vehicles, allowing a crew member to fire downward at infantry attempting to climb the hull without opening a hatch. The concept addressed a genuine tactical problem. The execution introduced a different one. As the bullet traveled through the curved barrel section, it fractured against the inner wall. Post-war testing by American ordnance officers found that rounds frequently broke apart before exiting the muzzle. Effective range drop, ed to around 100 meters. The barrel itself cracked and failed after firing approximately 300 rounds. Around 10,000 of the 30-degree version were produced. Documented combat use was rare. No reliable accounts of the weapon influencing the outcome of any engagement have survived. Project Pigeon. B.F. Skinner was a behavioral psychologist at Harvard. In 1943, the National Defense Research Committee gave him $25,000 to develop a pigeon-guided bomb. The device consisted of a standard bomb casing fitted with a nose section containing 1 to 3 pigeons, each sitting in front of a small lens that projected a live image of the ground below onto a screen. The birds had been trained through operant conditioning to peck at images of specific target types, specifically the shapes of ships. When a pigeon pecked the screen, a signal adjusted the bomb's control fins to bring it onto course. Multiple pigeons were used in parallel as a redundancy measure. In laboratory conditions, the system worked. Skinner demonstrated it to NDRC representatives. The committee declined to fund further development. The official explanation was that the technology was too far outside conventional weapons engineering for the committee members to evaluate with confidence. The program was terminated without a field test. Skinner maintained for the rest of his life that the guidance accuracy achieved in laboratory conditions had exceeded anything available electronically at the time. The Vampire. By late 1944, German infantry units on both fronts were being issued a night vision system fitted to the Sturmgewehr 44 assault rifle. The ZG-1229 Vampire consisted of an infrared spotlight, an image converter tube, and a battery pack. The entire assembly weighed around 35 pounds when fitted to the rifle. The battery for the spotlight was carried in a wooden case on the soldier's back. A second battery, fitted inside a repurposed gas mask container, powered the image converter. Effective range in total darkness was around 100 meters. The system operated in the upper infrared spectrum rather than the thermal spectrum, which meant it detected reflected infrared light rather than body heat. Approximately 50 Panther tanks were fitted with a vehicle-scale version of the same technology. The infantry system was issued in limited numbers during the final months of the war. The soldiers equipped with it were designated Nachtjäger, night hunters. Documented engagements in which the system was used as a primary rather than experimental capability are scarce. The concept was correct. The weight, the hour constraints, and the operational window in which it was deployed made it a technical achievement that arrived without an army capable of using it effectively. Who? Me. In 1943, the Office of Strategic Services commissioned a chemist named Ernest Crocker to develop a stink compound for use by the French resistance. The intended application was simple. Resistance operatives would spray the compound onto German officers in public. The resulting odor would undermine the officers' authority and erode the perceived legitimacy of German occupation forces among the French population. Crocker tested a range of candidate compounds at the National Research Defense Laboratory. The final formula combined elements associated with vomit, rancid fat, human waste, and sulfurous decay. The packaging proved nearly as difficult as the chemistry. Staff at the Maryland research laboratories who worked on the dispenser mechanism regularly contaminated themselves during testing. The compounds adhered to skin and clothing and resisted washing. 600 units of the compound, which was designated Me, were manufactured and prepared for distribution. The war in Europe ended before they were deployed. None were used operationally. The problem that had never been solved during development was that the compound, on contact, was as likely to mark the person applying it as the target. The V1. On the 13th of June 1944, 1 week after the Allied landings in Normandy, the first V1 flying bomb struck London. The weapon was 25 feet long, powered by a pulse jet engine that ran on 80-octane fuel, carried an 850-kilogram warhead, and flew at around 400 miles per hour at an altitude of between 2,000 and 3,000 feet. The pulse jet produced a distinctive buzzing sound audible from a considerable distance. Londoners called it the doodlebug. When the fuel ran out, the engine cut off. The silence that followed lasted approximately 12 seconds before impact. By September 1944, more than 10,000 had been launched against England. Around 2,400 reached London. British air defenses, including fighters, anti-aircraft guns, moved to the coast, and barrage balloons destroyed a significant proportion before they arrived. A Hawker Tempest pilot, finding his cannon had jammed, flew alongside a V1 and tipped it off course with his wingtip, causing it to crash in open ground. That technique was used with some regularity. The V1 killed around 6,184 people in Britain and injured more than 17,000. It was the world's first operational cruise missile, though the designation did not exist yet. The V2. The first V2 struck London on the 8th of September 1944. Unlike the V-1, it arrived without warning. The rocket traveled at approximately 3,500 miles per hour during its terminal descent, reaching the edge of space before arcing back down. It carried a 1-ton warhead. No interception was possible with 1944 technology. The only indication of an incoming V-2 was the supersonic crack of its passage heard after the explosion. Around 3,000 V-2s were launched against Allied targets, primarily London and Antwerp. They killed approximately 9,000 civilians and military personnel. The total explosive payload delivered by all V-2 strikes combined was less than the bomb load carried by a single large RAF bombing raid. The program cost the equivalent of several $billion in modern terms. The Underground factory at Middlework, where V-2s were produced by concentration camp labor, killed more people through the conditions of production than the weapon killed on impact. Werner von Braun, the program's technical director, was brought to the United States after the war. The V-2 became the direct ancestor of every ballistic missile and space launch vehicle developed in the following decades by both American and Soviet programs.